Right. So if you look at the left side, it's kind of a combination of human and the machine, uh, whatever which has been there. And then if you look at the right side, there is a human who is just looking at the data and its spread and all those things. That itself shows that how this technology AI is going to be assisting the humans in terms of coming up with cognitive kind of a decision making in various stages of construction project. Right. If you look at traditional construction projects, as I already told you, it is very much lag in terms of its productivity and a lot of waste and a lot of information loss. So if you look at this, one of the study shows that it has been done in 2017, if I'm not wrong, and I can say that this holds good even now. The statistics remain same. So around 30% of the projects do not meet the original program. I mean, it get delayed. And 92% of the information, whatever which is there generated during the early phases of the project, is not going to be available when it comes for planning the construction project, as well as managing and maintaining the facilities. And during the construction progress, you could also evident that 37% of the materials used to become waste. 10% of the cost due to the change orders, and then 38% of carbon emissions, which is produced out of the building, is also a concern for us to look into it. So if you wanted to optimize any of these things, then you could have all those different interventions which we can actually come up with. So you could see that there are enablers in the x-axis, and then in the y-axis you could see the opportunity or the potential for improving the productivity, by implementing the best practices. And a study showed that the McKinsey study, I mean, which is going to come again and again because I'm one of the big fan of this McKinsey's reports. So they said that 7 key levers which were identified that it could improve the productivity by 50 to 60%. Think about it. You can improve your productivity by 50 to 60% if you could actually utilize all these interventions and other things which are being listed in the slide. So among this, you could see that the technology has a great stake on it. If you look at this, it has a stake of 14 to 15%. If you try to adopt the technology, you could see that 14 to 15% of the productivity in all the processes, whatever which you are going to, introduce technological interventions, you can have an improvement. So this is the outlook or insight from this. And then if you look at this particular slide, again, this slide, I'm showing it again and again until I feel that these technologies are prevalent in the AEC sector. Otherwise, this slide is going to be there in all my presentations. Probably some of you, if you could have attended or happened to attend any of my previous presentations, you could also get a feel that why this guy is actually showing all these things. Yes, I'm going to show this unless until the industry is going to adopt to a significant level of these technologies. I mean, these are all the technologies which are going to be, improving the construction productivity, which are there in some of the parts of the world, and which has been demonstrated with greater improvement in the construction processes. Right? So if you look at this, the number 6, right? Number 6 is something that is the point of attraction for today's lecture, which is nothing but dealing with big data and then coming up with predictive analytics. So what is big data and what is predictive analytics? If you look at construction life cycle, millions and trillions of informations are going to be produced or generated. Where these informations are going to be stored? Yes, there are some informations which are stored as a mandate by the client or the government agency, and there are some information which just diminish or it kind of a volatile in terms of nature. So we don't have a a kind of a method or a platform to capture all the data, whatever which has been generated out of the project lifecycle. But if you look at the amount or the quantum of data that is going to be generated in the construction project, in any construction project, which is going to be spanning from millions and trillions. Okay. So all these data are kind of, a clue for us to make our decisions in each and every aspect of our project lifecycle. Or even its impact is going to be, greater during the service life of the, or during the life cycle, the later stages of the life cycle of any particular project. So big data and predictive analytics is something which is going to have an impact in almost all the other technologies, whatever which has been mentioned over there in the slide. So if you talk about building information modeling, yes, it does have a big data and predictive analytic capability. If you have 3D laser scanning and photogrammetry, yes, it does have, intelligent object recognition, techniques and all those things. Okay, and then when it comes for cloud and real-time collaboration, when it comes for wireless monitoring, each and every technology, whatever which has been mentioned over there, has to adopt a big data or a predictive analytic or a AI or a machine learning or some form of it into it to improve its output or its efficiency. Okay, right. So if you look at a study which has been again conducted by McKinsey in 2018, these are all some of the various processes that any AEC sector company or stakeholder is going to exercise. So if you look at this, there are three categorizations that they made. Back to office, back in the office, what are the tasks that they are exercising? So for example, resource planning, estimating, CRM, capital financing, risk management, all those things are happening back in office. And then what is happening inside is being given via testing and training, robotics and automation, laser scanning, drone enabled yard inspection, compliance, and all those things, right? And then what is being enabled with the digital collaboration, that has also been mentioned, machine learning, deep learning, laser scanning, and all those things. So if you look at this nexus, you could understand that each and every aspect, whether it is back office or on-site or in the digital platform, all are going to be collaborating with each other or all are connected with each other. So each and every aspect of deep learning or machine learning, which is going to be today's topic of our interest, has an impact in each and every processes, whatever which has been mentioned over there. So there are greater amount of potential for this particular topic. Right. So let's see that, people are talking about machine learning, data driven and all those things, right? What is it? I don't understand it. What is it? If somebody has such kind of a question, I can actually give him kind of a simple exercise that, assume that I would like to go to, Madurai from Coimbatore. Madurai is my native, right? So if I wanted to go from Coimbatore to Madurai, I'm not sure about the route, and I'm not sure whether there is a construction work going on in one of the route. There are multiple options, right? So if I just click in the Google map, it comes up with three kind of suggestions for me, right? 438, 51, and then 107. This is the place at when a human intervention is required. I, as a person, can choose either NH44 alone or NH44 and NH81 or something else, right? Otherwise, I can also leave it to an autonomous vehicle, which is going to be there, coming as a new normal in near future after 10 years or whatever it is. Most of the government started talking about smart cities and all those things. So probably we will end up with autonomous vehicles and other things. For example, 20, 30 years back, if you are asking about drones and other things, which is, we might have seen all those things in the sci-fi movies or whatever it is, right? Now it is very common, right? So the same thing is going to be there. We are not going to go away from the technology. Either we adopt it or we are going to adopt it after some time. That's it. I mean, whether we are going to utilize the technology or embrace the technology sooner or later. That's it. There is no other choice. I mean, this is my opinion, and you can also agree with me or differ with me. Yes. So there are some level of human intelligence required, choosing this, but it can actually give me a predictive time frame. You look at this, the first one, you could see that, 4 hour 30 minutes and 5 hour 1 minute. What does this is going to assist me? This predictive analytics is going to give me kind of an assistance to say that, no, don't go this way. I mean, this way is going to have some amount of a traffic. You see that, there is something like some traffic which exists over there. I mean, let me pick the pointer. You take the pointer. Yeah. So look at this particular line, some traffic as usual. And this is the fastest route now due to traffic condition. I mean, and then as well as the kilometers are less. I mean, these are all the information which typically I used to search for, right? So in say before this Google map or whatever it is, assume that I'm trying to do the same exercise 10 years before or 15 years before, for example. So I could have actually called one of my friend, in Coimbatore, and then ask him that, which route is going to be, more suitable or quicker or, less in terms of distance or whatever it is. He may tell something, and then he may tell that, no, I'm not completely okay. Maybe you can ask another friend. He's the frequent traveler or whatever it is. These are some of the things which used to happen. Now technology made us kind of a kind of a whole world as a global village, as people used to say, right? All these information Google has actually, buried inside, and then it processed and then give me in the form of ready to eat, okay, ready to absorb this information, and then, make my decisions accordingly. Okay, I mean, there are stories again. I mean, I'm telling you, there are stories where the technology also leave us into an adverse situation. I mean, I'm sure that you might have come across that, how Google fooled some of the people to end up in the middle of a forest or something or whatever it is that used to be surfaced in most of the, WhatsApp and all those forums and other things, right? But still, if you look at the number of occasions in which Google has given us a predictive, analytics, is going to be, has a more success rate, I can say, right? And again, the data input plays a major role. I mean, I would say that, based on my experience in, say, in Gulf and in Africa, right, whenever Google's information is being there, then people used to say that, you rehydrate it. But in most of the occasions, whatever, almost 99% of the occasion, whatever which has been predicted by the Google was true in my, experience. Okay, but if you ask me that what is happening with India, it is not that particular success rate of 99%, but it is around 70 to 80%. Again, it depending upon the data by which it is going to be built upon, right? What I'm trying to say is the input matters a lot. Okay, right. Okay, so how does this digital transformation, which is going to bring savings to the AEC industry? So we are going to build usable digital data, and most of the times, in near future, we are going to introduce all these technological interventions where the human interventions are going to be reduced, or our human interventions are going to be enhanced. I would say, I would use the word eliminate. I would not use the word eliminate human intervention. I would use the word something like it will assist the human intervention in terms of coming up with, data processing and data storage and all those things. And then this data is going to be shared among all the stakeholders so that it gets updated, and then I can have a data-driven decision making. How does this data-driven decision making is going to help me? For example, in the previous case, in the map, if I would have chosen the second route, then I could have been delayed by 1 hour, and then I could have consumed 20 kilometers extra, right? So that is a saving. I mean, I'm just giving you an example of a transport or transportation logistical, side. But you can also have so many, savings, so many interventions and then efficiency which can be realized during your building life cycle using the data-driven analytics or predictions, right? So how does this occurs? So the data is going to, the data is going to be there, and you can ask, does this data exist in those days? Yes, it does exist, but most of the time our efficiency is getting affected because we are reacting. Like in the sense, we might have chosen the second path and then react. Oh, this has taken 5 hours. I should have taken the other one. It's kind of a reactive. There were no proactive. So if I wanted to be proactive, yes, it was there. It was there in the past as well. People are proactive as well in their project, outcome or project processes. In which it requires a lot and lot of interventions which need to be, or analysis which need to be made within the organization and its processes, right? So for the example of this transport between one place to the other place, if I want to listen to, more people, I could have come to a proactive conclusion that, I'll choose the 4.5 hours journey or whatever it is instead of 5.5 hours, right? But what AI is going to give us is something called a predictive analytics, whatever which has been shown. It is going to give you that if you choose this, this is what is going to be your ending. This is what is very much required, and this is what which is going to be leading you to the efficiency in your processes. Okay, sorry, this is sorry, I'm going back. Yeah. And then I'm not going to actually discuss about this AI, ML, and DL. Like artificial intelligence, machine learning, and deep learning. I'm sure that people, the previous speakers have already been discussed about it, but just to give you a feel that machine learning and deep learning is going to be part of an artificial intelligence, and if there are enough amount of human intervention required, but the data processing is going to be done by the pre-programmed manner, then it is called a machine learning. And deep learning is something like you add intelligence to the computers and then come up with decisions. That's it. You are mimicking the human neurons and neural networks, or how the human neurons functions. Like the brain functions. And as I said, it is a mystery. Even the previous speakers have said, the more the design aspects and the constraints and other things which you introduce in the deep learning, the more efficient outcome that you can get in that autonomous processes. Okay, right. So this is the basic differences between machine learning and deep learning. And then artificial intelligence, as I told you, that it is a part of machine learning and deep learning is a part of artificial intelligence, right? And then again, it has the machine learning also, have so many subdivisions like, reinforcement learning and so on and so forth, right? So all those things you will come to, know when you dive into this particular subject, right? So what is being considered as a scope of AI on the civil engineering applications? These are all some of the things which has been surfaced in the literature, which I just put it as a snapshot. You can also just put AEC industry and then all these terminologies with AI in Google Scholar, and you could plenty and plenty of papers, plenty and plenty of case studies and demonstrations which has been there around the world. So list some of this. I would say that it can prevent the cost overruns. You may be asking how. I may say that if the project is performing at the halfway and then performing with so much of a CPI, cost performance index or whatever it is, then with the data, with the past historic data of the company and of the locality, it'll typically predict and then tell us that if you go in this way, then this is what. And then if you introduce the intervention, then it can also give you kind of a informed decision-making capacity or capability. And then again, AI is also being used for design now, better design. There is a new kind of a buzzword which is surfaced around BIM, which is called generative design. I'm sure that you might have come across this. The generative design is nothing but human can evaluate limited number of alternatives. Like suppose if I wanted to orient my building, I may be actually oriented in 3 or 4 directions, right? But the generative design can actually evaluate it in terms of, say, hundreds and hundreds of alternatives. What if it is 1 degree north to 1 degree to the north, or 2 degree to the north, 3 degree to the north, and then you can come up with something which is going to give you or reduce the total energy usage over the period of time, or throughout the year, and all those things. It's just give you an example, I'm telling you. Okay, I mean, I'll also show you some of the examples which has been there in the literature in the forthcoming slides. And then risk mitigations, again, the tower crane planning and all those things can also be introduced. Project planning, and also the AI will make the job site more productive, because you are making a decision in a predictive way. I mean, informed, in a well-informed way. Safety, and then AI also will address the labor shortages, because it improves the productivity. It shows improvement on the efficiency in site, and it also supports the offsite construction. And then this whole big data is also going to be used for us to process it for our next bidding or whatever it is. Suppose your company has say 100 project data in the past, and the number of success rate is lesser, and you can also come up with an analytics which can show you that where you have a success and where you have failures, and you can also come up with what might be the reason for the failure on the bid and all those things. So that's something which you can do it. And then AI has a very, very vast application in post construction, like during the service life of the facilities. That also been there. For example, if you want me to tell, like, I mean, nowadays it's all those air conditioners and other things are coming up with mobile apps and other things, right? What you need to do is you need to look at your 1 month consumptions and other things, and then the apps are intelligent enough to tell you that, no, these are all the suggestions that I can give you to practice it, to introduce, or to reduce your electricity bill or whatever it is. I mean, I would also would like to mention something like, I mean, there is a building in Abu Dhabi, I'm not sure what is the name of that building, where the facades are going to be, or the shades are going to be dynamically moving based on the direction of the sun rays and other things, to optimize the lighting as well as the thermal comfort of the building, so that the total power consumption or energy consumption or the carbon footprint left by that particular building has been very well being controlled. These are all some of the things that I can tell as an example. Not all these things are going to be given to you as an example, and this is one of the video which I would like to actually show it to you, because this particular video is something which is telling about whatever which we are using in our project in IIT Palakkad, and I'm going to actually show you the snapshot of that after this. And let me remove this. Yeah, please let me know if the video is not playing in your screen, because I may need to change the screen or whatever it is. Let me see that. I mean, let me try. If you don't, please, the organizer, please let me know. Okay. Right. This will run for 4 or 5 minutes, and I'm not advertising for this company.
No, actually, in the screen, it is not running, sir.
It is not running. Okay, right. Let me stop the sharing, and then I'll share it again as a video. Just give me a minute. Yes. Okay. I am going to share this, and then tell me if there is an echo or something like that, which you can experience. Okay. screen. I'll go with my entire screen. Can you see the video? I mean, it's from the YouTube one.
Yes, sir.
Okay, just
Sir, actually the audio is not coming and we are experiencing some.
you're experiencing what?
It's not continuous, sir. Actually, I think there is a issue with the bandwidth.
So I remove the microphone and then I will also mute my microphone. Let's just see that how it goes.
Family reunions, although every time I share the story there, they say, unless you have calluses on your hand, you're not in construction.
Sir, actually, audio is not streaming.
Or would want to read them every single day.
Instead of hiring a team.
Okay, sorry. Is it okay or?
Now it came, sir. Actually, now it came.
Okay, right. So I should not use the microphone. Okay.
Of people that go in, look at their data for the last 10 years and categorize and cleans it, they can have a machine learning model that looks at that data.
From data and start making recommendations, and once they're trained, they can start predicting things based on what they've learned.
What's really interesting about machine learning to me is the application of it.
In the past, folks have had to fill out long forms whenever they want to capture any information on a job site. We have seen checklists with more than 150 items. Machine learning can drastically simplify this process. In the future, people can just take a photograph, and from that photograph, as it said, a picture is worth 1,000 words. It's also worth 1,000 insights, and all this information can be automatically extracted, and that long checklist can be automatically filled out.
There's a lot of knowledge in the construction industry. The problem is most of that knowledge is locked up in the head of a superintendent who's been doing it for 30 or 40 years.
But when they leave or retire, all that knowledge goes away with them. And now how do you build that knowledge set again? And machine learning is something that can help or augment that experience because it can learn from the data.
If we can capture that knowledge and turn it into an assistive app that you can hand over to a young, bright, college-educated person who's interested in construction, you can help them be more effective. So you can set up the industry for the next generation, and you can also address the labor shortage. Choosing the right subcontractors for the right job and finding that fit really matters. Pre-qualification is often done purely on the basis of financial analysis. Is this company solvent? Do they have the correct amount of insurance, et cetera? So what if we could combine your historical knowledge of those subcontractors and the actual work they did on the project with the financial analysis to help make sure you get the right subcontractor for the right job?
That is some place where AI and machine learning can tremendously help.
You can have a great electrical subcontractor, but maybe they're more experienced in one project type than another. All that information we think will also help upstream in procurement.
It's not just about improving the quality of a construction project. It's also about making sure we can identify safety problems, safety hazards on job sites.
One of the things that really surprised me when we started looking at construction safety was the number of fatalities in this industry. In 2017, there were 971 fatalities in construction in the US alone. OSHA, the US body for health and safety, believes that more than 60% of those fatalities are completely preventable.
The world that I'd like to see is that we take the guesswork out of a lot of this and we just surface what you need to know when you need to know it and where you need to know it. So sensors that are monitoring job sites, ImageRec that can detect a problem and point it out to you. If you're a superintendent, the AI can say, hey, go look at this. There's a welding issue downstairs that's creating a safety problem, and that can get automatically detected, automatically send a notification out to everybody on the team.
Being able to understand risk before something really bad happens on a job site can prevent some of those injuries and fatalities and keep the folks on the job site safer.
If we saved one life, it was worth it. If we keep one GC or subcontractor out of court, it was worth it.
I truly want the next generation to think of construction as a really exciting place to work. I have a young daughter, and I want her to be excited about construction 10 years from now. This is where we see a great opportunity where we can help change an industry, how things are done, and make it really a better place.
What we're doing with AI in construction, I think, is really interesting, but the number of problems that can be solved by us, by partners, by the ecosystem, I really believe it's unbounded.
Okay, right. So I'm going to go back to the presentation again. I hope you still can see my screens. I mean, can you see the presentation now? Are we back to the presentation?
Yes, sir.
Yeah, sir.
Yeah. Okay, right. So now this particular pre-node or whatever it is, oh my God, it's started. Okay, right. Sorry, I'll just go on then. Okay, right. Okay, so if you look at this is something which we exercise in our site, in our campus construction projects. I mean, I have already mentioned about our project. I mean, in many of the occasions during my previous presentations, right? I mean, our project is campus construction projects, which is worth of now the first phase is worth of around 1,500 crores or whatever it is. I mean, around. And then the first phase, phase 1A, is being awarded to a contractor, and then and it is spanning in the space of 500 plus acres of land, and we have got all this design drawings and other things which has been done by the architect, and we went for a bidding, and then the contractor GC was selected, general contractor was selected. And still there are issues which are popping up because all these data are in DWG format, in drawing format. I mean, it is not collaborative. It has not been coordinated well and all those things. So there are a lot of issues which used to occur. So what you are seeing now here is there are issues which are open, these many numbers, and then which are answered by the relevant parties, these many numbers. And then where these numbers are going to be attributed, again, it is going to be there in this, the second, second row. You could see that, for example, the design issues which are answered by different parties are here mentioned. I mean, with this analytics, I could easily now, with a click of a button, I can call the CPWD and then ask them that, what happened to this particular thing. Otherwise, what happens is, I mean, I'll tell you a simple intervention, whatever which we made in this, and then how it has been improved. It used to be 2 weeks to 3 weeks to resolve an issue, design issue. That was a practice before we introduced this particular BIM 360. Okay, and again, I'm telling you, I'm not advertising for any of the companies. And before, I would say that before introducing the CDE, common data environment, the common data environment collect the data from various stakeholders, and then it does these predictive analytics, and then it do give us kind of an insight to the managers, so that their early interventions are going to be made to resolve the issue. Okay, so now after the introduction of this, we could actually resolve any issues related design issues, more or less 90% of the issues within 3 days. Think about 2 to 3 weeks in the past, and then it has been done within 3 days. How much amount of time which has been saved? How much impact which has been avoided? Because if the design information is not there, then typically it is going to affect the construction. and the construction productivity is going to be affected, then the whole project success is going to be in question, right? So this is based on our personal experience, and I'm just giving you a snapshot of whatever which has been realized, but none of these data has been published so far. So it will be there, at the end of this particular project. You would also see the systematic, benefits, whatever, or the analysis, whatever which we are going to experience in this particular project by the introduction of common data environment. Right. And then the concept of generative design, which has not been used here in our project, but it has been widely used in many of the projects in the Western world. And then the reason one is, I think I'm not sure whether you guys heard about this particular project, something called Dubai Museum of Future or something like that. Just Google it or YouTube. You just go and then find it out. It's like a crescent-shaped building, crescent-shaped buildings. It's like a crescent-shaped building. So you could see that, the building envelope is like a crescent, it's like a moon, a half moon. Okay. If you look at the amount of, design alternatives, which has been evaluated by the designers and the architects and the people, the other design consultants, is been enormous. And I would say that hundreds and hundreds of alternatives are evaluated. If you look at the traditional way of evaluating the alternatives without this generative design principle, or without this machine learning or predictive analytics principles, then you may be taking years and years of design process to complete to come up with an optimal solution. Okay, so what happens in this is you are giving a data as an input, and you also introduce the variables and constraint. It generates options, and each of the options are analyzed with the base metrics, and then you rank them based on, okay, it should be having this much of electricity consumption, it should have this much of a points in terms of aesthetics or utility, etc., etc. So you would get a score. Based on the score, you can rank them, and then you can come up with a design solution which are best among hundreds and hundreds of alternatives, which typically we ignore in our manual or a traditional way of doing the design design decisions, I would say, right? Now this is generative design, and another example in the construction side, which evaluated the constructability related exercise. It is evaluating whether the crane has to be there in this particular side or to the other side. What is going to be the sequence that is going to give us? These are all the constraints, and you could see that all these loops and the network, whatever which has been given, are constraints which are going to be posed with this by different actors or different processes and different materials in the site. You could see that crane is going to be affected by, say, for example, the truck which is going to deliver the material, the labor who is going to work, the sequence in which it is going to happen, this construction is going to happen, the availability of the material, and so on and so forth, right? There are so many aspects which all are having, posing kind of a constraint or an impact on your project outcome. Most of the time what happens is, in the conventional way, we look into a significant ones, whatever we think as a significant ones, and then come up with a local optimized solution. I mean, we don't think of a global optimized solution space. I mean, this will give us kind of a global optimized solution approach. And then another AI application which has been exercised even in India is this one. This is done by L&T. So they have deployed the autonomous vehicle at site to do the grading and compaction and all those things. Okay, so you could see that this is the conventional construction of how it has been done, and then how it has been done with the AI assisted one. And you look at the number of labors which are reduced, but doesn't mean that these many labors are not going to get any job or whatever it is. They may be deployed in some other places where you can get kind of a more efficiency when compared to these kind of a job, where the machine can perform with, in a more efficient way, and then it also eliminate the human safety hazards, and then it will also prevent differentiation between daylight and the night construction related activities. Okay, so if you look at the setup, whatever they have is, they have got a satellite controlled GPS, and then they have got the local base station. I mean, they send the information to the satellite and then back to the back station, and then from the back station, the corrections and other things are made with the advent of AI and machine learning. Because it is something called exercise called reinforced learning. So the data which is available now is going to be sent to the existing premeditated algorithm, and then it reads it, it understands it, and then it gives us kind of a suggestions or the solutions for us to maximize the efficiency. So this is something which has been exercised in India, and which has been practiced, and which has been demonstrated with a greater amount of benefits. Okay, right. So these are all some of the snapshot of what is happening in site. I mean, you would also see some of the excavation exercise which is happening in site with the intervention of the data analytics. Okay, and then one more, intervention which I haven't seen it here. I'm sure that some of the municipalities or corporations are exercising it in terms of controlling their traffic lights and all those things. But one of the things which I experienced personally when I was there in Gulf is one of the app called Dubai Police app. Because there the police controls the traffic and all those things. I mean, so what used to happen is, whenever there is an accident or incident or whatever it is, or a congestion or something, the app will automatically locate your own, position, your vehicle's own position, because you are driving and your mobile is with you. So it tells you that the road ahead is congested. So you could have taken the other, the bifurcation or something like that, so that you can reach your destination wherever you wanted to go in that direction quickly than this one. So it is a kind of application which exists with the help of predictive analytics. Okay, it can typically tell you that the route is congested and it will take 15 minutes to 20 minutes to clear it off and all those things. So that's something which is going to be helpful for the industry to come up with. Right now, when it comes to Indian AEC sector, this is the last one slide. We need to think about how the disruption of AI is going to happen in Indian sector. It completely depending upon the technological infrastructure, whatever which we have, and the physical infrastructure, whatever which we have, the skill sets, the human resources, and then policy interventions, what is required, standardization, because the more and more predictive analytics that you are talking about, the more and more you have to standardize in your all aspects of our processes. And then you also have to change the people mindset. I mean, I'm sure that in those days, whenever we have the technological intervention shown to our grannies or somebody's, they used to say that, no, this is not good. Or even in an organization, if you go and then show them kind of a newer technologies and other things, they may say that, no, it is not going to help us. So that mindset change has to happen. And affordability, of course. I mean, it's all, bit of a costlier now, in my opinion. Then it has to also come down. I mean, the more adoption will bring down the cost. So this is the summary, the last slide. I'm leaving it to you guys. Where are we now in terms of our industry? How matured our industry is, how prepared our academia and policymakers are to welcoming these technologies, because these technologies are practiced in almost all the developed nations. And if we wanted to claim ourselves as a developed nation or developing nation, then we may need to actually adopt it, sooner or later. And then what would be the next step, for a shorter time, 0 to 2 years, below 5 years, and within 10 years, what is going to be the steps that we need to take upon. So with this, I'll wind up my session. Thank you all. And if you have 1 or 2 questions, I hope there is time to address.